Hey, welcome everybody to lesson number 4 of Unit 8. We're finally into probability itself. So this unit was counting in probability, and we learned how to count. And we needed to learn how to count in all the different types of situations when we finally get to probability itself. And you might notice that this says probability part 1, and that's because there are two parts to this. There's a part 2. We're going to talk about like very basic probability and how it works for this lesson, and then we'll get into some slightly more advanced. Believe me when I tell you that probability is very, very advanced. You can get into calculus, which is where it becomes really cool, but also very difficult. I had some tough times with probability because it looks so easy until you start to think about how do you have to count stuff up and how do you account for certain situations. So anyways, let's just get right into it. Let's see what probability is. So you have a couple of vocab terms. You want to pause and write these down. You have experiment, which is any happening where the result is uncertain. Right? That's an experiment. Don't know what's going to happen. But you do have outcomes, which are possible results. Okay? Your sample space is the set of all possible outcomes. And then finally you have an event, which would be any subcollection of sample spaces. So when you're looking at something like rolling a six-sided die, the experiment is that you don't know what's going to happen, right? This die could roll and land on a 1, or it could land on a 2, or it could roll off of the table and fall into a crack and you never find it ever again, right? That's always an uncertain happening that could possibly happen in that experiment, right? And those are all possible outcomes, the results that could happen. The sample space would be the set of all possible outcomes. So if we were to look at rolling a six-sided die, right, you know that you could roll a 1, a 2, a 3, a 4, a 5, or a 6. So those are all the possible outcomes. This would give you your sample space. And an event would be any sub-collection of those sample spaces. So I could talk about maybe just the evens, right? In which case, this would be our subset collection. Okay, so those are just each of those different things. That's all that's helping you out with. I'm not going to be too concerned about asking you to define what is the outcome, what is the event. You should be able to distinguish that type of stuff, but that's not exactly what I'm interested in here. We're more looking at the mathematics behind it. So, we're going to look at the sample space for each of these experiments. And if we flip a coin, right? If we flip a coin, you could either flip a heads or you could flip a tails, and that's really all that could happen. Yeah, could somebody just kind of come up and like snatch the quarter away from you before it lands? Yeah, but that's not really something that we're too concerned with happening here. Right? We're talking about perfect world. So let's look at if we flip two coins. This gets a little more interesting. First of all, the first coin we could flip might land on heads, but the second one could also land on heads. That's always a possibility. Or we could flip heads the first time, and then this time the second one lands on tails. Right? That's always an option. Or we could flip tails twice in a row, or we could flip tails and then heads on our second flip. Right, so we have covered every possible combination, right? Heads, 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 tails, 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 and tails, heads. So when you try this one here with 3 coin flips, make sure you stay organized because you're going to have to want to keep track of all those. So try this one out. Pause the video and resume when you're ready to check both of these. All right, so I told you when you do these to be careful and organized. Organization is probably the biggest factor here. Right? If I flip 3 coins, I could do heads, heads, and heads. I could do heads, heads, and tails. I could do heads, tails, heads. Or I could do heads, tails, tails. Or I could do tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Or tails, tails, tails. I think that's all of them. Yep, that covers pretty much all of them. Double heads, double tails. Yeah, that looks like all of them. So there's 8 different possibilities of that. What if we flip a coin and roll a 6-sided die? Okay, well, you could roll flip a heads and roll a 1, heads and a 2, heads and a 3, heads and a 4, heads and a 5, or you could do heads and a 6. Sorry, this is weird. That's a 4. Or you could do a tails 1, tails 2, tails 3, tails 4, tails 5, or tails 6. So those are all of the possible outcomes you could get there. So as you can see, depending on what different events or what kind of experiments you're looking at, you can have all sorts of different events and outcome situations. So let's see how we can start applying this probability. So here's probability. Okay, probability is a very basic thing, and let me tell you, the fact that it's so basic is what kind of makes it so interesting, because people can do really well with it and other people can struggle, and it's really this is what probability is. But the question is not just solving this, it's figuring out what these functions themselves are. That's the tricky part. So anyways, probability. If an event E has n number of E equally likely outcomes and its sample space S has n of S equally likely outcomes, then the probability of event E happening would be the number of outcomes over the sample space. It's actually pretty cool. So we're going to look at that a little more detailed. Basically, this is what you're going to do. You're going to figure out how many of the things that I want to possibly happen out of all the possible results there are. All right, and because this is a fraction and we are taking a subspace of the total, that means that we're going to be getting a number between 0 and 1. We're either going to get 0 out of the whole or the whole thing out of the whole. So like those are the only boundaries that we have. We can't get more than the whole, and we can't get less. So our results are going to be between 0 and 1. That being said, the lower or closer to 0 you are, the less likely that event is to happen. 0 would be impossible for that event to happen. Like, for example, the probability of rolling a 7 on a 6-sided die, it's not going to happen. There are no 7s there, so it would be 0 out of 6, which is 0. But if you look at something like flipping a coin and landing on heads, there's only 2 options, heads and tails. So you have a 50-50 chance, is what they like to call that. It's just as likely as unlikely to happen. And finally, a certain event would be something like if I remove all of the face cards and the aces from a deck of cards, so I'm only working with the numbers, the probability of me pulling out a number is going to be certain because I'm only pulling out numbers. I took out all the other cards. That wasn't the best example, but you get the idea. The closer to 1 you are, the more likely the event is to happen. Better odds, some people say. Which is technically a different thing, but that's different. Anyways, so 2 coins are flipped. What is the probability that both will land on tails? So we already looked at the total. We said heads, 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 tails, tails, heads, and tails, tails. Right? So there are a total of 4 different outcomes that we could have. That's our sample space. And then we'll know what is the probability that both will land on tails. That only happens once in the sample space. So the probability of this particular event E is 1 over 4, which if you type into a calculator is going to give you 0.25. Now again, we want to write it in decimals, and I know if you know me, you're gonna probably laugh hearing this, but you want decimals in this particular instance. Mr. Marquetta usually likes fractions. Don't give him fractions here. Give him decimals. And how do you know where to round? If it doesn't tell you where to round, give as many decimals as you possibly can until you feel comfortable that it's a reasonable answer. I will have to make sure to tell you what to round to on a quiz or a test, but if it doesn't tell you, just put down a good amount of numbers to work with. Alright, so here we go. We've got this problem. What is the probability of drawing a 10 from a standard deck of cards? Well, if you don't know this already, write this down in the notes. There are 52 different playing cards in a deck of cards. There are 4 suits, and they all repeat. So if there are 4 suits, that means that there would be 4 tens in a deck of cards. And we're talking about out of an entire standard deck. So 52 would be my sample space, all the deck of cards in it. And there are 4 tens, so 4 out of 52. That's what we're going to type into our calculator, 4 out of 52. So that gives us 0.7693. Right, it keeps on going. So like I said, it doesn't exactly tell us where to round to. So this is a pretty good solution. It's giving us a lot of information. It's a little bit over 3/4. Not over 3/4, I'm sorry. I have that decimal in the wrong spot. Alright, it's not a very likely thing to happen. Sorry, that decimal's in the wrong spot. So if we look at this, 0.076923, much less likely than 3/4 to happen. Anyways, be careful that you don't make that same mistake that I just did with the decimal being in the wrong spot. Math, the rest of it was all accurate. Just please be aware of that. I'm not going to record this. It's already 12 minutes in, so deal with it. Let's see. What is the probability of pulling out a blackjack from a standard deck of cards? That's the one that you're going to try right now. So pause the video and resume when you're ready to check your answer. Okay, so you should know that in cards there are 2 different colors. There's red and there's black. And if there are 4 suits and 2 different colors, that means that there's 2 of each in a particular color. So if we're talking about jacks being black, there would be 2 out of the 52 standard cards. So 2 out of 52. I'm going to be much more careful this time with my decimal. 0, 3, 8, 4, 6, 1, 5. We'll just end it right there. That is your probability of pulling out a blackjack. So if you've ever played blackjack with a standard deck of cards, that's the probability that happens. You have like a 3% chance. Alright, another one for you to try. Pause the video and resume it when you're ready to check. So, you're flipping 3 coins and you want to know the probability of all of them landing on tails. Well, we had already said heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, 1, 2, 3, 4, 5, 6, 7, and then tails, tails, tails. So that's all of the possibilities. I think we saw this earlier, but they want to know all of them landing on tails. That's only one option. So that's 1 out of 8. 1 out of 8, or 1 divided by 8, is 0.125. Alright, we're going to look at some other types of probability. That was some very, very basic ones. But you can also have some pretty interesting ones. So you're going to need to pause this to copy this down, I'm assuming. So if you wanted to take a second to do that now. So we have jelly bean flavors by color category. Okay. First you have the green category, which has apple, jelly beans, watermelon, supermint, and grape. You have red jelly beans, which are strawberry, cherry, red raspberry, and cola. You have the blue color category, which has blue raspberry, blueberry, cool mint, and cotton candy. And finally, you have the yellow category, which has lemon, banana, and summer squash. Summer squash. And then you notice that in this particular bag, you have so many of each of these, right? 14 apple, 7 watermelon. Okay, so we have a good amount of information to work from here. they're asking us some questions down here, like what is the probability that you would randomly select a green jelly bean? If that was the first one, you open up the bag, and rip it open and pour one into your hand, what's the probability that you will randomly select a green jelly bean? So they give us different categories. Green is one of these categories, but we need to know the overall sample space. So the overall sample space is all of these jelly beans in here. So what we're going to have to do is we're going to have to calculate, we don't have to, but we really should calculate each of the totals for all of these categories. And then if we add all those up, we'll get the total altogether. And that will help us out because they're going to be asking us some random stuff throughout. Right, so let's figure out this one first. 14 plus 7 plus 4 plus 10. It's a total of 35. So you got 35 green types of candies. Here, 11 plus 17 plus 2 plus 9, 39 red jelly beans. You got 12, 18, 1, and 3, so 34 blues, and then finally 6 plus 15 plus 3, only 24 yellows. So these are the individuals for the categories. Overall, inside of this bag, 35 plus 39 plus 34 plus 24 is 132 jelly beans. So now we've got a lot more information, but it's broken down even more specifically for us. So we can answer this first question. It says, what is the probability you would randomly select a green jelly bean? Well, in that event, there are 35 green jelly beans out of 132 total. So you have a 0.26515 probability. A little bit more than a quarter. 1 in 4. Not bad. What is the probability you randomly select a mint flavored jelly bean? So now this is a little bit different because we have super mint and we have cool mint. Super mint there are 4, cool mint there's 1, so there's a total of 5 mint flavored jelly beans out of the 132 in this package. So 5 out of 132. 0.0378 7, and then I'm going to round the last one up to a 9. So you have a much more likely chance of flipping a coin tails 3 times in a row than you do of pulling out a mint flavored jelly bean from this bag. Got one more question here. Right, it says if you randomly select a non-fruit flavored jelly bean. Non-fruit flavored. Alright, so let's go through here. Mint is not fruit. Strawberry, cherry, red raspberry, cola is not fruit. Blue raspberry, blueberry, cool mint, and cotton candy, those are not fruit. Lemon, banana, and summer squash, not fruit. So we've got to add up all these numbers. 14, 7, 10, 11, 17, 2. Some might argue that blue raspberry is not technically a fruit because it's not a real thing, but it's still fruit flavored, so we're going to keep it. These two don't count. 6 and 15. So I got 112. So there are 112 fruit flavored out of 132. So if we take 132 and we get rid of the 112, that would leave us with 20. I kind of did that backwards because I misread this question. So let's just count the non-fruit ones. 4 plus 9 is 13. 14, 17, 18, 19, 20. Alright, so that'll work out in the end. 20 divided by 132 is 0.1515. It actually repeats. So it helps if you read the instructions carefully, right? Non-fruit flavored. So we counted up all the fruit ones. We came up with 20 by subtracting from the total, but we really didn't have to do that. We could have just counted these all together. So again, make sure that you read the instructions a little bit better than what I did, but we still came up with the correct solution there. So you have one try here. This is dedicated to the class of 2020 right now. Or I guess not class of 2020, but the kids in my 2020 classes who are stuck inside right now for this quarantine thing, thanks to COVID-19. So I know that you guys are stuck inside watching Netflix. So here's one for you to try out. I want you to copy this chart down first. So pause this and copy the chart. Okay, now I'm going to give you a couple more minutes to work on these three problems. So again, pause and resume when you're ready to check your solutions. Alright, so let's see. You're stuck in quarantine. What's on Netflix? You have TV shows, movies, and documentaries to choose from. And then it tells you that there are 14 comedy TV shows, right? 7 daytime talk shows, 6 sci-fi, 17 action. So if we add all those together, that's a total of 44 TV shows to choose from. You have 3 classic, 8 kids, 11 drama, and 13 comedy movies for a total of 35 movies. Then you got 9 animal, 15 space, 2 criminal justice, and 1 biographical documentary. And if you were to somehow randomly pick out, right, you got 44 plus 35 plus 27 for a total of 106 movies to choose from. So now we know our total sample space is 106. We have different categories kind of added up already. They want to know what's the probability that you'll watch a movie. So movie has 35 options out of 106. So if you randomly somehow selected something out of here, you would have a 0.33019 probability of selecting a movie. What's the probability you'll watch a comedy? Well, comedies come in TV shows and in movies. So if you add 14 and 13, that would give you 27. Out of 106 possible. That's going to give you 0.25472 probability. That means that the comedies take up about a little bit more than a quarter of what you could possibly be watching. And finally, what's the probability you'll watch a sci-fi? Well, there's only 6 out of 106, so 6 out of 106, 0.0566. That, I guess, would be a good thing if you're not really interested in sci-fi movies. Anyways, that's your first taste of probability. Those are very basic ones. We never even talked about like jelly beans inside of a bag. I guess we did. We definitely did talk about jelly beans inside of a bag. So we went over some very basic probability, including jelly beans in bags and movies on Netflix and everything else. So hopefully you're starting to get an idea of what probability is. The next probability, part 2, is going to be talking about much more specific situations, including what happens if we have overlap, or what happens if we have different categories to choose from. So if you enjoyed this little bit of probability, I think you'll enjoy some of the other stuff a little more. It gets kind of a little more exciting in the different possible scenarios. So I'll see you at that next video. Bye.